Hi, in this video, I will show you what are leaf curves and how you can use them to communicate your machine learning results with your business stakeholders. Hi there, I'm Kelwin Fernandes, your AI advisor, and welcome to another AI shot. Today on this video, I will show you one of the most undercover, non-mainstream tools to discuss business results from your machine learning models with your peers, which are the leaf curves. Okay, so everybody talks about technical metrics such as the ROC curves, such as the precision recall curves, accuracies, etc., or business metrics such as the average revenue per user or customer lifetime value, etc. But the leaf curves are by a much better tool to communicate with your business stakeholders about the potential impact of any AI model. By the way, in the description there is a link with a bonus PDF that will help you talk with your stakeholders on what is the right expectations that you should set with your leaf curves. Okay, so let's talk about what is a leaf curve. Okay, a leaf curve is nothing else but the result of ranking your customer base, your prediction base, so the base of the base that you are trying to optimize, regardless of whether they are products, customers, or whatever. You are ranking them on an incremental coverage, for example, from 0% of the population to 100% of the population, and basically the top cases, the best cases, according to your ranking of the margin you can gain or whatever, are on the left side. And then on the vertical axis, you have the gain multiplier. Okay, what do I mean by the gain multiplier? I basically mean how much better is your machine learning model on those than a random model. Okay, so if a random model, let's say for example for a problem of lead scoring, okay, you know that your customer base converts on average at 3%, okay, and for a certain percentage, let's say 10%, on the top 10% of the cases, your model puts cases that convert at 30%, okay, then your model has a leaf on that top 10% of 30 divided by 3, which equals 10, a 10 multiplier, a 10x multiplier, okay? So basically you just build these curves incrementally, accepting more people in your ranking and computing what is the boost, the lift, the gain that your model have versus a random model, versus just screening your population randomly on this case. Okay, so you should expect something like this. Okay, so your models should be super good at putting the top cases on the top, and or the best cases on the beginning of the ranking, and then as you have to include more and more cases, you will see that your leaf will decrease. In the worst case, of course, you will have a multiplier of 1. Okay, so basically this case here, when you have to cover 100% of the population, you are optimizing nothing, because you have to tackle each and every lead or each and every point in your customer base. And in that case, you have a leaf of 1 because you are not better than random if you are not ranking or optimizing anything. What is relevant about this is that basically it gives you a notion of how much you are optimizing, right? Because basically if it puts your model in a context of how much better it is than a random strategy. Okay, in this case I'm saying random, but you can also compute the leaf versus the current strategy, which is basically which is your benchmark, which is your baseline that you're trying to beat now. So it puts you in a context of how better you are with respect to that strategy. Okay, and you in general you should expect a leaf curve such as this one. You can see opposite behaviors if you are worse than random on the top cases, but I guess that's not the case because you are a good data scientist, a good ML engineer, and so I guess you will have a curve such as this. Okay, so I like them because they put the model in context, in a context where it's not just longer a prediction, it's a prediction plus a way of operating, a way of operationalize, of putting those predictions in practice, such as let's rank our customer base and let's contact the top 10% because that matches our budget, and it gives to the business a certain context of what is the expected impact that they will perceive with the AI model. So you will see a sales multiplier of 1.3. So they have a 30% expected higher margin than what they have at this point. For example, if you are ranking leads, most likely you will, if you are doing lead scoring, most likely you will rank your leads by the top, from top to bottom, according to their probability of conversion. And then you will say, I have a budget for sending this to the top 10% of my customers, of my leads, sorry. And this will have a multiplier of 1.5. Okay, so I expect to sell 50% more than my current approach, or than a random approach, just contacting 10% of the leads at random. Same thing, for example, for patients. If you are scoring patients according to the likelihood of getting better with a treatment, you know that you will be allocating the resources in a better way than by randomly assigning treatments to the patients. Same thing if you are, instead of a binary case, let's say a more challenging case, let's say you are ranking assets by the potential margin you expect those assets to have, and then you just have to sort them by the expected margin, from the ones from the top case to the bottom case, and then knowing how much better you did with respect to the baseline, to the random scenario. Okay, so it's basically a multiplier that compares two methods. In general, one is random, but you can also put your baseline model, your baseline business strategy that you have as now in your business. Well, if you like the video, of course, remember to like and subscribe. But let's go for the main disadvantages of the lead course. The first one is that it's quite sensitive to the hit rate, to the baseline hit rate. So let's say that your initial model, your initial lead base doesn't longer convert at 3% because you change your SEO strategy, your copywriting, etc. Now you convert at 5% or at 6%. Just by changing your baseline conversion rate, you will change dramatically the scale of your lift curve, because you are basically dividing the performance of the model, let's say model, divided by baseline. If the baseline changes, the results will change dramatically. Okay, so and that's the main issue. So in general, what I do sometimes is I normalize the lift curve. So you will observe that an optimal lift curve will be to rank all the leads that convert at first. So this will give you the maximum multiplier, the maximum theoretical multiplier you will have, and then this will start to decrease on an optimal theoretical case. And so what I do is I divide this green area, which is my lift curve, divided by the potential lift curve, which is this red area here. And I can also put this now in perspective and say, I have a multiplier of 1.5, so I'm 50% better than the current strategy, and I am 70% about to reach the optimal capacity of the optimal scenario of the lift curve. Or I'm only on 10%, if you are kind of bad, or if you are, ideally you will be on this curve. So you can have both how better you are than the business and what is expected opportunity size if you keep working on improving your model and get a better lift curve in the end. The other issue with the lift curve is that, just remove this, is that you need to choose a budget. Okay, so you need to choose this case here. Normally, if you have a higher budget, you will optimize less because you will start doing recommendations, or you will start working with the worst cases. So your lift curve will tend to get worse at that point. If you have a smaller budget, you will see a higher optimization level. Okay, but you need to know what is the budget. Otherwise, you will be communicating results that then won't be reliable. For example, let's say that here we have a lift of 2. But then in the end you have a much larger budget and your actual conversion was 1.1, and they say, you promised me that you will gain, you will be twice as good as the current strategy, but now you're only 10% better. What happened? Well, it's not that the AI model got worse, it's that they started to use the worst results of the AI model. So that's the second issue. Actually, I had a client that as a standard rule, they use the top 10% always, like this part here. But then in general, they send the campaigns to the top 30 or 40%. So they were always getting worse results than what they promised to the business, just because they were using an improper reference point to communicate the results. Okay. Then the final issue, but it's much more of a technical issue, is that it's quite tricky to optimize leaf curve directly with the current machine learning techniques. So in general, you optimize for a different metric, your loss function, your final objective function, and then you just validate with the leaf curve. But since it's a ranking metric, it's kind of tricky to directly optimize. Okay, now how to use the leaf curve? What I often do is I communicate with the business what is the actual budget they have, and I use the ratio that leads to that budget. Here by budget, I'm placing a 10%, for example, of the customer base, assuming the top cases, so assuming all cases have equal cost. But if you have dynamic cost on the customer base, you can just run them, and then just knowing the budget, choose the threshold here that covers that budget. So the budget doesn't have to be a fixed percentage of your population. Can be a dollar amount. Let's say I'm willing to spend about 100K. I know that the most difficult case will cost me $10, the other will cost me $5, the other will cost me $1, and the others will cost me 10 cents. If you know the values, you can just write them and use the threshold here that matches your actual budget. Okay, and then I often use the leaf curve as a guideline for my initial pilot. Okay, by building a margin of safety above the worst case, which will be the 1. Okay, so I basically say, well, you know what? I know we have a budget of 30%, but we will be entering on a risky area where the optimization is about 10%. So let's reduce the budget during pilots. Let's do a smaller pilot, only let's say on 3% of the population, where we have a leaf of 5x. So we have a huge margin to be wrong, and still make some profit. So initial pilots, I typically, set a smaller budget, and then as I gain confidence on my AI model, I increase the budget as long as I see that I'm still in a good region of my leaf curve. Okay, so tell me, there are any other metrics that you use or any other tools that you use to communicate the results with your business stakeholders? Tell me in the comments. Remember to like, subscribe, and activate the notifications. Hope to see you soon. Bye bye.